and welcome to the Open Spring Inspire Hackathon final ceremony event. Today, after more than 2 months of hacking, we are going to conclude the hackathon, and we are going to have a pleasure to acquaint you with the top 3 teams selected by jury, and you will learn about the winning results of the Open Spring Inspire Hackathon. My name is Anna Kubíčková. I'm going to be your host today, and I'm pretty sure the most of you knows me very well. But anyway, I will introduce myself very briefly. I work for Plan for All, and I'm mainly responsible for organizing the Inspire hackathons. So that's why I was pretty sure you know me. But now, back to the hackathon and its quick overview. The Open Spring Inspire Hackathon was focused on developments and innovations in agriculture, the environment, transport, tourism, geospatial applications, or remote sensing. We started already in March with definition of all 11 relevant series of challenges, and during months of April and May, participants seek solutions for the challenges under the guidance of more than 20 mentors. In this hackathon, more than 60 hackers took part and represented 17 countries from Europe, Africa, and South Asia. The hackers' expertise fell into the smart agriculture domain, and it encompasses data collection, data analysis, data decision support system. As you can see, the GIS has a centric role in this hackathon, and the community is interested in remote sensing, agri and food systems, mitigating climate change, and secure food supply. In this hackathon, we had the honor of having a total of 8 members of jury. The jury team, Bente Liaby, Karimi Ouhary, Lilia Nungu, Josef Noil, Denny van den Broek, Teresa Shamanová, Geringai Kamau, and Pavel Kogut. And the jury team was asked to read all 11 final reports and evaluate the results based on the predefined criteria. Throughout the whole hackathon, all teams and mentors did an excellent job, and jury had an incredibly difficult task to select top 3 teams out of 11. If anyone from jury is here, I would ask to announce the 3rd place. I can see Teresa Shamanová here. Teresa, can you please tell us who is the, where goes the 3rd place?
Yes, just a second. I need to prepare myself. Can you hear me properly?
Yeah, we can hear you.
Yeah, hello to all. Yeah, and I will a little bit prolong the delay before announcing the 3rd place, which goes to Smart AfriHub 3, African Agricultural Water Security. So congratulations to the winners of the 3rd place on behalf of our jury, and we are really happy to see the results of your great efforts and your product presented within this hackathon.
Yeah, congratulations from myself as well. Do we have someone from Smart AfriHub team here? I can see a message in chat. Yeah, Tula is celebrating. And okay, I will now share with you the results of Smart AfriHub.
The 5th challenge is called Smart AfriHub 3, African Agricultural Water Security. There were a lot of participants, it was 18. Among them were 8 guys from Africa. One of them will speak today. His name is Ronald. And then also another speaker will be Karel, whose contribution is very welcome. So Ronald, the floor is yours.
Thank you, Marketa. I don't know what to say. Is it good morning or good afternoon to everyone? But my name is Semba Ronald, as Marketa has indicated. I was part of this hackathon, and I'm from Uganda. I work as a agrometeorologist with the National Agriculture Research Organization. I guess that's enough about me. So let's head straight into this. Taking you through the background, this hackathon, this challenge specifically builds from a couple of different Inspire hackathons that have been running through, from the Nairobi Inspire Hackathon to the COVID Inspire Hackathon and the Kampala Inspire Hackathon. So we have a couple of results from different hackathons that we've combined together in what we've called the Digital Innovation Hub, or which you can call Smart AfriHub, and a couple of other social media links. So we have also been working together with 3 different challenges in this hackathon, and that is Challenge 1, Challenge 2, and Challenge 3, which is about analysis of Sentinel-1 and Sentinel-2 time series for application in agriculture. So next slide, please. So now we go to, this is our composition. We have members like Marketa has indicated in the introduction, from different countries all over the globe, as displayed in this map here. We have a 3-pillar approach that includes the datathon, whereby members gather together to collect relevant data. And in this case, we've cited different data sets that would help in analysis and identification of analysis of the identified problem, which is potential farming, potential irrigation systems. So another component of, excuse me, I had to get off this screen display here because I couldn't see well the screen. Our other approach is Ideathon, whereby we gather together and process different ideas and plans on how to go ahead and provide different solutions. Another component or approach is the Educathon, whereby we combine different learning tools and sessions and train different individuals or members in this group, in this challenge, on use of different tools such as geospatial analysis tools and different communication tools in different platforms. Next slide, please.
Okay, as Ronnie mentioned, we develop also a number of data during the datathon, and for your information, this time we focused too much on the development of the platform, but on the publishing of the data of the platform. And all data sets which was developed, you can see if you will open opening page of Smart AfriHub, only clicking on some of this image and you will be directly moved to the map. So Ronnie, you can continue.
Okay, thank you, Karel, for that. One of the first things we had to do is to assess the current status and needs so as to answer the different challenge we have, questions, the different challenges we had at hand. And one of the things we've actually gotten to discover is that from a combination of ideation sessions and the available literature, we've learned that the biggest portion of agriculture of water in Africa is claimed by agriculture. However, only 6% of the total land in this region which is actually roughly 185 million hectares, is under agricultural use, in this case, cultivation. And actually, worst of this is that about 6% of this is under irrigation. And this sort of like highlights the food insecurity problem in Africa, because it turns out that the sector is largely rain-fed, reliant on rain-fed agriculture. So solutions are sought to curb this problem, because the rapidly growing population in this region of Africa is posing many issues as regards food security, of which various effects are associated with this that include the insecurity and that include the malnutrition and conflicts in different areas. So our solution here is that we thought for solutions and realized that there's need to optimize both land use and irrigation potential, so as to increase agricultural production and productivity. Next slide, please. Well, and right here, we realize that there's not going to be a one-fit-all solution that can really span the different human and natural dimensions. So we thought to put together a combination of approaches and tools to optimize the available open source observation resources and data and tools, so as to inform government and local farmers on policies and just-in-time farm or local level decision making and intervention. So these include mapping of land use activities, which include a number of methods and classification tools that Karel will discuss later. It also included monitoring of vegetation conditions, because this helps in informing real-time intervention. What needs to be done, when and at what time, how much water needs to be added when and at what time. And we also intended to monitor water resources, their conditions, their quality, their amount of available water resources, because a combination of these will inform the right decision that is needed by the local farmer or governments in Africa. Karin.
Okay, as already Runar mentioned, we work a lot with the data, and to analyze the situation in Africa, we try as first to collect available Pan-African data and making this easy accessible, and together with challenge 2, attractiveness of region, we also compare situation in different countries of Africa. On Smart AfriHub, you can see the result, and the challenge 2 will much more deeply presented how this comparison of countries was done. For this water irrigation crop monitoring, we work at first stage mainly on the development of open land use for Africa. The main problem is that the data which now exists for Africa are in very small scale and with lack of detail and lack of information, and we thought how we will be able to improve this data. You can see two data sets which cover all Africa and which could be used, but you can see the level of the detail. Already in past hackathons, we work on open land use for Africa to combining this data with local data and to try to improve the data, but all it was not enough, and together with challenge one, which define the multi-layer model for open land use, which is done now in Europe, we try to use this model in Africa, and we think how we can make much more detailed maps and how we can combine this with other data. And because this multi-layer model, there is some basic geometry, and then you are able to put into this data different thematic view. So we decided to take existing data of land use and combine this with probably the best data set which exists for Africa, and it is OpenStreetMap. And on the base of the combination of this data, we built the basic geometry for countries in Eastern Africa, covering Kenya, Tanzania, Uganda, Burundi, Rwanda, and we cover all these 5 countries with these maps. And we started also build thematic view on this map, combining different inputs and building different type of thematic maps for these countries. What is important that this multi-layer model is able also integrated results from Earth observation data. You are able to combine this with indexes or with classified data, calculate the statistics, and make then some assessment of this every area, and to make much more precise classification. Here you can see some statistics which was done for single areas based on non-supervised classification. So we calculate for every area which classes of unsupervised classification are inside of every polygon, and then we provide classification of this polygon. This is way how we are able to combine existing vector data with Earth observation data. It is in some way based on ideas of GeoBia methodology, and we see this as a big future for monitoring of Africa and to building maps which will be able to help by for countries, but also for regional organization. As I mentioned, we work a lot of with different type of indexes. Also, Ronald mentioned that it was important for providing some assessment. We compare different indexes, including Sentinel-1, but also Sentinel-2. As probably you know, Sentinel-2 is able to work also through the cloud. So you can see that on some data up from Sentinel-1, you can see here clouds. But if you are Sentinel-2, but if you are working with Sentinel-1, there are no clouds, and you have this data for all periods. So in the combination of different type of the data, we are able to receive better classification and better interpretation of the things. On the hub, you can find the series from all season of all 3 types of the indexes. So you can also follow on the hub the development of vegetation in this region. Due to the limited time and resources, we done this only with one scene from Sentinel-1 and Sentinel-2, but now there is already methodology which could be extended and done in larger scale. Other topic, as Ronald mentioned, was the monitor the quality of the water. When we start to visualize data from water, we were very surprised because we saw on the images strips. And we thought, where is our mistake? What we are doing wrong that there are such strips on the water? But then we start to study literature and look on this, and we recognize that it is something what is common for this data from Sentinel-2, and so that we need to in the future deal with the problem that there are these different strips. We then look on a different combination of spectral bands and indexes, and on this and we select participant 5, and we prepare some visualization. You can see that there is on this spectral band is possible in the water to see the different effect, and of course this effect has to be later studied. Again, the time was not so long to compare this with
Please, I would like to ask you for muting yourself. Thank you. Or Pavel, could you please mute Jesper?
I will try.
There is a huge noise from Jesper. Pavel, I'm not able to mute. So could you please mute them?
Yeah,
Thank you very much. Thank you.
My pleasure.
Some samples, but this is the base for future activity. This was from this data work, and I think that, Ronald, you have now to conclude our presentation.
From the above. Okay, now from the above presentation and results, we present our conclusions as below. Our community is one that is always expanding, and we're having to develop a number of content that is being published at the hub that can be used all over Africa in different ways. Also, the new ideas and analysis of needs in African farming sector have been collected, analyzed, and visualized. So we think all this content can really be applied differently. And the good thing about it is that this kind of data and analysis are presented in very high resolutions that can spark high level and low level decision making. Our next steps is developing more tools to analyze and assess the quality and validity of the generated results, and also working together with different geospatial stakeholders like the geo community, the Copernicus, and all these different players in geospatial data and analysis to promote these results in different African states and different groups. So my concluding remarks would be that this is quite a huge potential that can be harnessed in all these different results and open data that has been availed at the different African farming sector players to utilize in order to improve productivity and production of agriculture at the continent and contribute to the different SDGs. Thank you.
Okay, so thank you all for your attention. Here you can see the contribution.
Yeah, so these are our details.
Yes, so I would like to say a special thank you to Tula, who maybe left already. But Tula, thank you. You're the heart of our challenge. It was great job done by you and by all guys. Thank you very much. It was a great time we spent together. So I hope our cooperation will continue. Really, thank you.
Thank you, Marketa.
So these were the results of the third place, and I would like to tell you some comments on this challenge which were received by jury. So the jury claims the achievements are really impressive and very good interaction with other Inspire challenges. Challenge 5 builds on experience of previous Inspire hackathons and will provide input to future editions, which demonstrates great continuity. Authors represent a multidisciplinary team with diverse backgrounds and geographic reach, very high number of participants, and jury also like access to existing communities of practice in Africa. So these were the comments from the jury. And now we can move to the announcement of the second place.
Thank you for the space, and I'll be happy to announce now that the second place goes to the challenge number 9. It's AgriHub for Slovakia. Yeah, so congratulations, and I do hope that the representatives of this team are among us and will be able to tell us more about their impressions.
Yeah, thank you very much, Teresa. Actually, I am the one who is here on behalf of the challenge number 9. So thank you very much for awarding us with the second place. And now you will hear more about the challenge number 9. Welcome to the presentation of results of the challenge number 9, AgriHub for Slovakia. Firstly, I would like to highlight the main goals of the challenge. The aim was to build a Slovak agricultural innovation hub that will become one access point for Slovak community, information, data, latest technologies and possibilities in the field of smart farming. It should also offer an environment for the development and emergence of new ideas and offer farmers data that will be transferred into knowledge so that it will be applicable for them. The overall aim of the hub is to connect actors from development, the public sector and research with the end users. Now, let me briefly introduce our team. With respect to the main goal of building Slovak Digital Innovation Hub, the challenge team was composed exclusively of colleagues from Slovakia who know best the agricultural needs and situation in their country and could thus guide the direction of the challenge solution. We were cooperating with Slovak University of Agriculture in Nitra, Technical University of Košice, ACEN, Kajo Services, New Edu, Res and GIS, and the responsibilities for the technical part of the solution were taken by Wireless Info. On the top of that, there was also a strong cooperation with members of the challenge number 6, analysis of Sentinel-2 and Sentinel-1 time series for agriculture purposes, and with the challenge number 1, dedicated to the improvement of the Open Land Use version 2. These two teams provided us with data analysis for agricultural land located in the vicinity of Nitra. Before we started developing the hub, we have defined following needs. Firstly, it is important to support close connections between research and practice. On one hand, we need to make better transfer of new knowledge to the farming sector, and therefore new results need to be included into new IT solutions, but also need to be transferred to all players. On the other hand, we need to support on-demand research, where research goals will be provided according to the real needs of the farming sector. Secondly, it is important to explain to all communities that we need effective cooperation, that the role of the public sector is not only controlling the farming sector, but that the public sector needs to become part of the chain and mainly support farmers with data and services to help them adapt future strategies, namely Green Deal. So we need to connect farmers with researchers. Developers need to be better linked with farmers' needs, but also with newest agriculture research. Thirdly, we need to integrate different types of data, such as geospatial data collected by Inspire Directive, satellite data, including those free data from Sentinel-1 and Sentinel-2, Landsat data, and also data from commercial satellite providers. Then we also need farm data, machinery data, core inlet cover data, LPIS data, etc., and use this data for preparation of recommendations for farmers. Then we also need data and technology infrastructure service. And last but not least, the innovation experiments. Because the problem of many new applications in agriculture is that they are designed without specific knowledge of the agriculture sector and without real interaction with farmers. So based on the defined needs, the AgriHub SK implements these components. On the very top, needs to be placed. Then we also need tools for data sharing and visualization, like HS. Seems that Jesper unmuted. Yeah, thank you, Pavel. Players, layman. We also need to include metadata catalog that will support search and access to data according to FAIR principles. Then we need to have on the hub the applications section where description of the current experiments will be placed in an understandable form. We also need to include Science Shop and forum for discussion with stakeholders and sharing the knowledge. And also the innovation experiments needs to be there. Now I will tell you a couple of words about technical background of the Digital Innovation Hub. The AgriHub SK is built on the Liferay portal, which is the framework which provides a robust platform to build a website quickly and serve it to all clients, like desktop, mobile, or anything in between. It provides all the standard applications, which I've already mentioned as needed, and it also provides an easy-to-use development framework for new applications or customization. The extension of the Slovak AgriHub is based on a cloud solution where Liferay is providing a user portal framework and background for front-end applications such as HSLayers NG, QGIS Layman, or Jupyter Hub. For the publication of datasets, the creation of map compositions, and the creation of metadata, AgriHub offers its own technological line where several open tools are involved. All these tools are separate, but in order to publish the data, these tools need to be seen as one complete line. In this slide, you can see how these components communicate with each other. You can publish layers, compositions, or just view them online using the aforementioned HSLayers NG, which is a web tool, or the QGIS desktop client. Then there is a component that is not visible to the user. It is the layman or layer manager, to which we supply geodata, and it processes it in WMS or WFS format, which are standards for publishing geospatial data on the internet. And along with the creation of geodata, we also create metadata, which is published in a metadata catalog called METSCA. These components, which I've just talked about, are covered by AgriHub SK, in addition to QGIS, which is a desktop client. As I already mentioned, the very important is to publish a data on the hub. AgriHub SK and its metadata catalog METSCA currently aggregate Slovak LPIS and services from the Inspire geoportal. On this slide, you can see LPIS data, and here you can see one of the services from the Inspire geoportal, which are water bodies of Slovakia. One of the results published at AgriHub SK is the Earth Observation Map application developed by a team of challenge number 6, who were dealing with the analysis of Sentinel-2 and Sentinel-1 time series for the agriculture purposes. This map application serves individual farmers, and the professional public to better understand the current state and development of vegetation in the field. The outputs from the application can also be used in the financial sector, food, and public administration. Crop development is analyzed using a time series of satellite images from the Sentinel-1 and Sentinel-2 satellites. At this slide, you can see the RVI index time series of Sentinel-1 data. Here is a supervised classification, unsupervised classification. And the second experimental example of the AgriHub SK is the raster vectorization, which is the outcome of the challenge number 1, how to use and improve Open Land Use version 2. And we find such experiment as an valuable input for the update of Slovak LPIS. Now we are at the end of the presentation, so we can say that the AgriHub SK was successfully designed and developed based on the needs. The platform was designed to create links between people, companies, and other entities with knowledge and technology that will help in the implementation of innovative projects and ideas. One of the principles is to connect ordinary users with developers and researchers. The second principle is the integration of different types of demo applications, where farmers, developers, and researchers will have the chance to collaborate, test different applications for new solutions, and also provide common experiments. And the third principle, and the very important one, is to make open data available in the Slovak Republic. We have aggregated Slovak LPIS data from Inspire GeoPortal, and outputs that arose from challenges number 1 and number 6. The experiments have shown that technology and data are usable for both for needs of farmers and for subsidy control. The platform allows easy cooperation of many stakeholders. An equally important outcome of this challenge is the submission of the proposal AgriHub CZ and SK to Smart AgriHub's Expand Open Call. The ambition of the Czech and Slovak Digital Innovation Hub is provide access points via AgriHub for Czech Republic and AgriHub for Slovakia that creates and connects the community, knowledge, data, and technology in both countries. So this is all from our team, and I would like to thank you for your attention. So these were the results of the challenge number 9, and at this point I would like to thank to the team of challenge number 6 and challenge number 1 who provided us with the data for the AgriHub SK. So thank you very much again. And now you probably want to know who is the winner of the Open Spring Inspire Hackathon. So Teresa, could you please tell us?
Yes, please. The moment of the highest tension comes, and the first place goes to the challenge number 7, interactive collaborative data capturing at scale. So congratulations on behalf of the jury.
Yeah, congratulations to all participants of the challenge number 7. Do we have someone here from the challenge? Runar, are you here?
Hello.
Hello, hello. We can hear you, Runar.
Yes. Now, well, I am here. We are happy, but I think you have a video from this, don't you?
Yes, we have, and we will we will replay it
Yes,
very soon.
we are, of course, deeply honored to have been considered in this. There's nothing more to say than that. It's been a fun task, and I should say that the least worthy person to speak of it is me. But I think Raitis is also here. So in terms of people who have had impact on the actual outcome, he should rank a great deal higher up on the list than I should. But please run presentation, and we'll see how it goes.
Okay, so let me share my screen and enjoy the winning challenge.
Collaborative data capturing at scale. This challenge deals with the technology called map whiteboards. Map whiteboards try to simplify the process of working together in a decentralized environment over a map. It digitalizes the process of working with a map in a physical meeting. It enables effective interaction between experts and non-experts with regard to spatial information, and it enables easy collaborative data capture in a decentralized manner. There is more to sharing a map experience than merely seeing the same screen. It's necessary for all connected users to be able to work with the map itself, to add, remove layers, to add and edit geometries. So there's a fairly big registry of different objects that the application needs to keep track of and to distribute to all connected clients. Clients to date can be either open layers based web map clients, or it can be QGIS as a desktop GIS client.
The map whiteboard library uses two kinds of requests for client-server communication. For requests which are either executed once when the map is loaded, such as retrieving the map definition, we use the REST. For low latency, small payload requests such as cursor position or spatial feature geometry updates, we use WebSockets. We store the spatial data in Mongo database asynchronously to minimize the overheads as much as possible. The REST API is described by OpenAPI or Swagger standard. Some of the requests, such as SLD, style propagation, or layer ordering, uses a combination of REST when the data is sent to the server and WebSockets when the data is propagated to the clients. Next I will show you a small demonstration of the developed system. We need to be authenticated to use the system, so let's log in. On the first screen we can see all the compositions which we are authors of, or the ones which are shared with us. Let's create a new one. It will be named comp2 and it will contain some initial data, some agricultural fields, and let's set this as the initial viewport. Let's save and load the composition, and I will do the same in the other browser window just to see how all the data is being synchronized. When one user moves the mouse, the cursor location is automatically synchronized between the windows or the users. And there is also a little small name of the current user which the cursor belongs to. Here on the right side we can see different panels for managing layers, adding layers, and doing all kinds of stuff on the on this map. Let's add a new WMS layer from Latvian State Forestry. Add to map, and the layer automatically also is shown in the other window. We can reorder the layers. So the vector layers are displayed on top of the raster layers, which is quite important when we are digitizing maps. And let's do some vector editing then. I can click on some vector feature and draw its vertices around, and the change is automatically reflected in the other browser window. I can also set the attributes of these features, and they are also synchronized. I can change the style of this layer. Let's go to the fields layer, click on this paintbrush here, and then let's add a new rule. Rules are used to set different styles based on filters by attribute values or current scale of the map. Let's set a fill symbolizer, which is used to symbolize polygons. You can see that the style is sent to the other window. And when the current editing is done, we can go to this menu on the top right side, go to Layer Manager, and then download the data as GeoJSON file, which can then be imported into other GIS systems. And it's also possible to download the metadata of this whole map, list of layers, name of the composition, like the initial viewport, and other properties, by clicking this download button, which will download the metadata in our custom map composition format. The map can be shared using this share panel here, where we can find users by their emails or usernames and then assign different permissions.
So, having seen the demonstration, we have drawn up some conclusions and next steps for the continued work with the map whiteboard technology. The results that we have arrived at to date includes an API specification that defines a RESTful API, including requests and responses, as well as WebSocket messages that need to travel between the server and connected clients. We have built a functioning map whiteboard server that sits centralized on a web host. We have built a software as a service self-service application where you can create and upload data, and if you don't have your own custom map whiteboard client, you can connect with the built-in map client on the same model as you would to a text document using Google Docs. We have a map whiteboard client-side JavaScript library that allows integrations with open layers, and we have a map whiteboard plugin for integration with QGIS. We have a number of technical frontiers to explore. To date, we have tested the scalability of the system to the extent that we know that tens, 20s of users can connect to a single map and it will work without any sort of degradation of performance. The next step is to scale that testing to ensure that hundreds of users can be connected to multiple different maps in parallel and work without any sort of degradation of service. The coding now has been conducted in a fairly compact team with few developers working on the code base at once. In the next stage, we will broaden the collaborative effort of development, and that requires more efforts into automated testing, code quality, and deployment. Thirdly, we would like to extend the authentication system that was shown in the introduction to the demo, and leverage people's existing social accounts rather than requiring them to make proprietary accounts for this tool, thus drawing in users more easily. Finally, as with all things, the map whiteboard needs to be made economically viable. We are exploring building integrations with existing communication tools because it's obvious that this would be a support module for existing online conferencing tools. So we would look into the APIs provided by Zoom, Teams, GoToMeeting, and the like to see if we are able to make an easy way to augment conferencing experiences by connecting web map clients and shareable maps directly in the interface. Furthermore, we need to elaborate one or more business models that can generate revenue from this, several of which have been discussed to date, including using this as a mechanism to label satellite imagery for machine learning purposes, using it as a communication tool between advisors and farmers, something which is instantiated by an example in the Rural Support Service of Latvia. And with that, I thank you for your attention. And should you have any questions or suggestions, please do not hesitate to contact either of us. Thank you very much.
So this was a report of the whiteboard winning team. So congratulations again. The jury appreciated a very professional, well-written and detailed report that reflects that the group took the time to explain their work and to guide the readers through their findings. Another comment from the jury is that the value the solution brings to different stakeholders is clearly illustrated through user stories ranging from farm advisors or public authorities. If implemented, the solution can generate a lot of commercial interest from public and private market players. And there is continuity in the proposed idea, which started at the first Inspire Hackathon in Barcelona. These were the results that were chosen. These were the winning teams that were chosen by our honored jury. And in addition to the jury evaluation, we also gave the public the opportunity to choose their 3 best teams. And here are the results. The winning team of the public audience is the challenge number 1, how to use and improve the Open Land Use version 2. So congratulations. The second place goes to Regional Attractiveness Challenge. And the third place goes to analysis of draft conditions. So congratulations to all winning teams which were awarded by the public. And now I would like to give a floor to Karel Harvat, who is the godfather of the Inspire Hackathons. So Karel, if you could say a couple of words about the Open Spring Inspire Hackathons, what are your impressions?
Okay, thank you, Hannah. At the beginning, I would like thanks to all hackers for this 2 months of intensive work and to bringing a number of very interesting solutions. I saw how it was evaluated by jury, and I think that the role of jury was not very easy to select what is the best solution. I would like start with something what I already mentioned many times. Yes, Inspire Hackathon is not event; it is process. Yes, and I think that this time was very well visible that there were continuation of activities that we compete, but on other side we cooperate. Yes, and sometimes some challenges sell the result of other challenges was not evaluated as winner, but without their contribution, probably the result will be not so good. So I think that this was the reason, and I think that it was really in the ideas of Inspire Hackathon to support innovation, to support some sustainability of the result, and to help to new result to be more familiar for other and continue in the work. I am sure that most of things will continue, that will be used in the projects or in the commercial way, and I hope that people was also happy to be the part of this big game, and that it is not last time when we met. We plan to continue in the autumn with other again fully virtual event seems, yes, but I hope that one day we will have again chance to meet all other and to cooperate. I am sure that there will be also some scientific paper and other results based on this. And of course, I would like mainly thanks to Hannah for managing all this process. It is not easy task. She was this time able also to participate on the work, not only be part of managing of the work. And okay.
Thank you, Karel. My pleasure.
And I hope that we will future. I wanted to mention that it was a part of Open Spring. We start mainly in the Czech, where we discuss with the community, because our goal is to bring the community to have with this community, and I am sure that this Open Spring in some way will continue. I don't know if it will continue till the autumn or it will start next year. And I hope that soon I will meet of most of us. And thanks you and bye.
Thank you very much, Karel. And just few words from my side. You are probably excited what is the award for winners and hackathon participants. Everyone gets a certificate of appreciation for joining our community and contributing to the work on challenges. The certificate will, with your name on it, will come to your mailbox few days after the hackathon, and the winners will be given the opportunity to publish the results in the scientific journal. Now, all that remains is to thank all of you for participating, mentoring, and last but not least, a big thank goes to our jury, which didn't have an easy job selecting the winning teams. So thank you very much and see you in the next hackathon. Bye-bye.
Thank you and bye-bye.
Bye. Bye.